Start. I'm gonna go to the door in the back. So you can actually hear the whole thing. What is it? So let's start.
Can somebody please close the door at the back? So let's start. Welcome. You have all reached the LSVR working group session. So for the next 90 minutes, we're going to be discussing that topic. So let's first start off with the beginnings here. So a few things actually happened. Now, before going into the content, let's first do some administravia. So we do have a JavaScript. We also have a minute taker. Paresh, thank you for that. So the minutes will be taken in Etherpad, Ethernote, or whatever the thing is called. If you would like to contribute, which would be very appreciated, then please, add your comments, particularly with names and so onwards, just to make sure everything is done correctly. So you have seen the note well already a few times. If going from the assumption that you attended at least one session already, if not, read this thing, be aware of that. Anything you say and do actually is part of the IETF, community here. So before we step into today's agenda, so this is what we have set up here. So first we're going to have like a few short notes on what happened in the last 3 months. That's going to be followed up with an update of with the latest document of the BGP SPF in LSVR. Then we're going to have like 3 different updates to do with layer 3 discovery protocol, followed with the updates from IEEE on the TLVs for LSVR, and also with LLDP v2 and the progress on where it actually exactly is. So that is the agenda for today. Any questions, anything that we need to swap around or discuss additionally? Okay, now let's go onwards. So if you look into where we are, at this point in time, and from where we started, I think our deliverables based upon the charter are like in reasonably good progress. We have a demo already available for the LSOE. We also have done a working group last call on the BGP SPF document that went successfully. This document has very recently been updated, so I was waiting for that for creating the Shepherd write-up and pushing it onwards. The document already actually also had some directorate reviews. There was a routing directorate review which came back with some issues, and those have been addressed in the latest version. So maybe Keyur can actually say a few more words later on in his update on where we are with the with the comments from the routing directorate and how we address those. And the ops director actually also gave us like a ready to go pass here. So everything is in good shape for the at this point in time for the Shepherd write-up. Then also in the last couple of weeks, we had an update on the applicability draft. So we will be doing a working group last call on that one very soon after the IETF, this meeting here, and then close that thing down also and push it together with the BGP SPF document for further processing. Now, also what we have seen in the last couple of weeks is we have seen some increased progress with the L3DL documents. And beyond the base specification, we actually are doing some further work to do with security, signing and so onwards, with some automation and configuration elements of it, and also to do with, for the technology itself to help out on services running on top of BGP SPF as an underlay, for example. And initially, when we started with this work, so from the LDPL perspective, it actually had some properties which went beyond the LLDP v1 technology, which required us to work on something like that, which included, for example, things like a bigger MTU size, a better handling of fragmentation and reassemblies. It implemented like a push model instead of like a periodical kind of update, and it also had some improved rapid recovery technology involved there. Now that actually triggered off also some progress in the work on LLDP v2 and take these particular elements into account for further progress also and work upon the LLDP v2 technology itself, for which we're going to be hearing like further updates from Paul in this session here. So that is where we are right now. So any questions, anything else before we start with the first session? Okay. Keer?
Looks like a big stage.
It's a don't tumble off.
Yeah. You sure it's not going to crash?
I don't know.
Good afternoon, guys. I'm going to give a quick update on BGP SPF. The draft version 6 was submitted right around the end of September, first week of October. Working group last call has been successfully done. We did get reviews. We have incorporated that in the draft. Implementations are now available. So as part of the last call, at least the working group last call, there were comments where folks came in and said, hey, it would be nice to sort of provide a mechanism to mark the node and at least say if the node's not capable of acting as a transit or cannot participate in SPF. And we have incorporated this mechanism through the status TLV that was already present. So we do now mark the node, and that would allow the node to appropriately participate within the SPF itself. We did also receive lots of NITs, and I think we'll take care of that in version 7. That is going to be posted post IETF. From an implementation update standpoint, we now have at least one BGP implementation that is fully conformant. We do have another open source implementation that's in works, specifically on FRR. And we have at least 3 operators who are looking to sort of start playing around with the code base in the lab. From the update standpoint, the Yang model for this SAFI is also defined, fairly straightforward mechanism. From the modeling standpoint, we want to start working on this models draft. We think we should have a common model for LS and SPF, and we'll take that work pretty soon. We'll publish the draft out too. We want to, as part of this new effort, we also want to write a protocol implementation draft and an experience draft that comes along with the implementation. From an implementation perspective, we have now an implementation from Arcus done by Pushpashish. Pretty much covers all the sections of the draft. There was, from an implementation standpoint, and I think we discussed this at the last IETF too, a challenge in generating a remote router ID because we do not have a hello mechanism that establishes the adjacencies. And as part of that, as part of this draft, we have sort of punted that either using LLDP or L3DL, and or else you can statically configure that and sort of build up the adjacencies. So that took care of it. Again, from an interop standpoint, when you receive the routes and when you install these routes into RIB, as the draft suggests, we do give this SAFI a preference over IPv4 unicast and IPv6 unicast, and that solved the problem pretty much from competing SAFI standpoint. From an implementation testing point of view, we have made sure we have enabled it with both IPv4, IPv6, as well as SPF SAFI, and seems to be working just fine. A little bit of test details on the test setup that we have tried this SAFI. We've used standard clause, leaf spine topology, 10K V4 and V6 routes with 32-way ECMPs. So you're looking at 320K paths for V4 and V6. Dual stack tested. Peering was done in band between leaf and spine. The early convergence numbers we have gotten suggest no particular convergence deviation from IGPs. In fact, this is turning out to be a little bit on a better side. That pretty much means that from a convergence standpoint, the SAFI is holding up pretty well. By next IETF and in the implementation update draft, we'll be posting some numbers with respect to how many updates were generated and do we see any optimized behavior here. A little bit of details on implementation 2 that's done on FRR. Again, it's implemented by Santosh from VMware. AFI-SAFI support for the BGP is pretty much done. Packet encode decode support is also done. He is actively trying out the encode decodes to make sure it's conformant with the ARCUS implementation. The SPF computation is work in progress, and post SPF computation, the route downloads would be the other part of the work that remains on this implementation. But we are actively working towards interoperability. 2 implementations are going to be out there. So that's all I have from the draft update. Any questions?
Alberto, you said you have a Yang document?
We are working on a Yang document.
Okay, so it's not ready. Okay.
No.
And then in that same slide, I think you have other drafts you said you wanted to write.
Yes. We want
what
to
are
write an
those?
implementation spec and a protocol experience spec.
Can you show the slide so I can?
One more. Oops. Where did it go? Yep.
Protocol implementation draft, what is that?
2 different documents probably. One would talk about specifically an implementation, specific details on an interop side. And the second would probably talk about how you would, what are the implications as you start to deploy this as a new technology within the class networks?
And that one is different from the applicability statement.
Yes. Unless you want us to write one draft and cover them.
I don't know. I mean, I would have to see the contents, but that second one sounds, closer. Okay, just wondering what those are.
Thank you.
AC Lindum. I just wanted to say that we tried for this base specification, we tried to keep the amount of function low. We didn't want to put all the bells and whistles that are in IGPs in this, especially since you already have the richness of BGP policy that you could apply any place. But if people see things that they think should be in this base spec that isn't, I as we were going through the implementation, I had one thing in my mind, and I'll discuss with the implementers. Let us know if there's something. Like, for instance, we decided we purposely didn't put areas in because we didn't think we needed them, and we didn't think the initial use case needed them. So that would be thing. That regarding Alvaro's comment about the protocol experience, we had that was a requirement for new protocols. Now, we haven't done a new protocol for a long time. We got a couple of them coming. So, you know, back in the old days, I remember there was these, you know, in order for a new protocol to get the protocol specification published, you needed the protocol experience. Or maybe that was just to go from standards. Maybe that was to just go from that's what it was. It was to go from proposed standard to, so we're doing one better than that, I guess. We're doing that initially, the protocol experience.
Thank you. Anybody else? Good.
Yeah, and just as a last point, we could probably solicit a working group feedback to that point. I mean, there's so much confusion within clause that a protocol experience draft would just help. But I mean, if you want to bypass that, happy to do that. Yeah. Thank you.
Okay.
Hi, I'm Randy. I'm from Arcus also. That just email address is older than Cisco. And Rob also works for Arcus. So this is a conspiracy. This is actually a sympathy play. I have to work with CAIR every day. Okie doke. L3DL, this is the 4th version and it hasn't changed much. So just a quick review. Remember, the primary goal is topology discovery for layer 3. Okay, the principal customer is our CAIR and AC, et cetera, SPF. Though I will reveal some other uses. Okay, just to review is, and you're not going to let me move, huh? It's a layer 2 protocol to get layer 3 data across. So here's what we're talking about down here. And I will not get into this time how it pushes it up to SPF because it's boring. So it's just a layer 2 protocol, single links at a time. It's not a routing protocol. It merely discovers the addresses on the layer 2 link, the layer 3 addresses on the point-to-point link, and announces them to each other. What's new? Details. Okay? So, want to be clear about PDU retransmission. The question is, should a PDU be retransmitted? If so, it must be sent as the identical set of datagrams as the original transmission. And the transmission sequence number informs the receiver that it is the same one. The sequence numbers are nonce. Okay? So every PDU, which is composed of lots of frames, has this magic number. It's sequential. It's obvious. Okay? And if a datagram, not the PDU, but if one of the datagrams in a PDU fails checksum verification, drop it on the floor. The sender will retransmit the PDU and the receiver can reassemble it. Right? Reassembly is, if you remember TCP, it's pretty similar. Okay? There was an oracle. There were 2 cases of authorization failure. Authorization in open and authorization in a non-open PDU. That formed an oracle that you could tell what the PDU type was by the error. So therefore now they're both one, just failure. Just security nut stuff. Okay, The transport layer can handle rather large PDUs, and it's really pretty clearly delineated. A datagram can be 2 to the 24th of them, 2 to the 16th octets in a datagram, except it has to fit probably in an Ethernet frame. So if you see Ethernet frames that good, you've got different classes than I do. Okay, so it kind of looks like this. These are datagrams, okay, with that transmission sequence number, datagram length, etc. Checksum, reassemble them into PDU, just like we do with TCP. Okay, and why not use TCP? I mean, why reinvent TCP? It's because we don't know the IP addresses of anybody. We're discovering the IP addresses. We'd love to use TCP. We'd even put it over TLS. So it's a cheap TCP-like protocol with state and all that stuff over layer 2, okay? Reassembly, transmission with backoff, PDUs are acknowledged, long-lived sessions, okay? It's fully stateful session per peer. So there's no chatter, okay? It's hard state. It's got graceful restart. State may be resumed on failure because in every PDU, there's a serial number. So if I lose the session, I can reopen and say, hey, this is the last serial number I digested. You want to take up where we left off? Okay. Duplicate datagram and PDU detection, retransmission on timeout, etc. One of the things that's been enhanced in this version is that in the PDU that's announcing and withdrawing addressing at endpoints, the actual protein of this protocol, the encapsulation flags are now, you can announce and withdraw single encapsulations at a time. You can say whether this is a primary address on an interface. You can say whether it's an underlay and overlay address, and this will get exciting in another 15 minutes. You can say whether it's a loopback, okay, for each encapsulation, for each address. Okay, there's explicit ACKs with errors. Error type code 0 is just an ACK. Everything else is an error. Vendor extension hasn't changed. Okay, we now have, as I think it was Gunther said, one Python 3 open source, one is in Golang that we're hoping to open up. It's going into our product, a FOSS, with interop, maybe in Vancouver. We'd like to start thinking about moving to WG last call. Okay. I can take question at this point. Otherwise, I'm going to go into the security and signing stuff and so forth. AC.
AC Linda, I think we better working group last call this, as it seems to get bigger every time we don't.
Pardon?
It seems to get more function, more capability.
Hasn't changed much in the last version.
Oh, well, okay.
I just, what happened really in this version is a bunch of advice about what to do, like how to do the retransmits, et cetera, that got exposed by a new developer implementing. The PDUs have changed negligibly. Tony.
Tony P. Juniper. So did you give any consideration to DCCP? I mean, the whole work has been done already to run TCP over UDP. It's published, RFCs, everything.
We did. Do you mean the IEEE trying to do
no,
TCP over?
It's IETF RFC, DCCP. That has been done. It's basically TCP over UDP, fully published with all the corner cases. So I wonder why you were not looking at that stuff. maybe you missed it, maybe there was something missing. Just a question in the room, because I see the same work pretty much, yeah.
But if it runs over UDP, doesn't it run over IP?
Do it. You haven't got an IP address. But
Okay.
it's a layer 2 protocol because you don't know layer 3 yet. If I knew the layer 3 address, I wouldn't use UDP, I'd use TLS. Sue.
This is
Who are you,
Sue
Sue?
Harris. Thank you. I think you fixed several of the retransmission concerns I had with this. Thank your developer.
Thank you. Yep. He was rather picky. By the way, his name's Harsha. He's not here. But he beat me up every couple of days. Okay. So, if you remember from last time, you can go to BES, and Neeraj extended it to do EVPN without ARP snooping, without all the crazy stuff that makes you throw that equipment away. Okay, so go to BES and see Neeraj's presentation on using this with 2 new PDUs for EVPNs. So way back when, I raised the issue of security, and operators said, yeah, we want security. I said, what's your threat model? And the room was silent. So I hypothesized a threat model, and I said, I'm worried about people plugging poisoned laptops in. I'm worried about people plugging strange devices in, et cetera, et cetera. So if you'll notice, the PDUs have, all PDUs are signed, or can be signed, or may be signed to be more proper. The open PDU may have a type of authorization that'll be used, the key that will be used to sign with the appropriate length, of course. Okay? The PDU is signed by the sender. The open PDU had the public key. The sender signs with the private key, of course, and the device sending the open can use one key for all links, different keys for the blue links, different keys for the pink links, whatever. We don't care. Okay, that's a matter of configuration. Okay, click. There we go. The open key is generated on the sending device. The private key never leaves the sending device. This is reasonable, normal key practice. With trust on first use, it's believed without question by the receiver. So here's my public key, you believe it. It's used to verify all subsequent PDUs from the same sender. So the sender is the same attacker you had yesterday. That's tofu. Sorry. You don't have to use tofu. You could have PKI based. So the key is generated on the device, and then the public key is sent to your key management infrastructure. It is signed by whatever private key is known in the system, where the matching public key is on all the devices. Okay, it's normal PKI stuff, but don't be afraid. It is not X509. Okay, it just is that the key, the public key, is signed by a private key, and that's it. None of the rest of the X509 glorp, you don't need it. If you are an organization that has an X509 infrastructure, of course you can use X509. Enjoy. Okay? Every device, though, to do this, must have burned in or distributed to it somehow the public key of the trust anchor of the PKI, so it can verify. But this gives you fairly reasonable signed PDUs. Okay? Verify, the two methods are indistinguishable. The key in the open PDUs to verify the signatures. If it's PKI based, it's just when you got the open PDU, you could check that the key was authentic. From then on, you're cruising. Okay? The choice of which type of keying is left to the operator. And in fact, they could mix and match. The pink peers get tofu, the blue peers get it PKI. Okay? And we'd like to request WG adoption. Would you like it to do it here or in email? Email would be preferred, I presume?
Yeah, email.
Okay. So, questions on that one? Sorry, some of us are security geeks, so we wanted to have the darn thing reasonably securable. You don't have to do it, by the way. You could have the key authorization type be 0 and no security at all. Right, sorry, I didn't mention that. So the purpose here is for KR and AC to be able to talk to BGP to each other. Okay, let's remember why we're doing this. So wouldn't it be nice if we could give KR and AC the information they need to build their BGP SPF session? Okay, so we have a PDU for building upper layer protocols. And in this instance, so it's a normal TLV with a protocol type, an attribute count, and an attribute list. And the attributes are the protocols. Want to provide the minimal set of parameters for BGP because open is going to exchange all the rest, and you don't want to be in conflict with the parameters exchanged in open because then you have two sources of truth, and my mother always told me that's bad news because then you have to resolve them. Okay, so what are the minimal parameters for BGP open? Okay, they are what is my ASN, what's my peering address, and what's the BGP authentication data. Okay, and yes, of course, there's one for IPv6. Okay, and that's it. That's all it is. Really dumb, really stupid, really simple, and you can automatically create your BGP sessions. Questions? Not even from Sewer John? There we go.
John Scudder, I'm only coming to the mic because you called my name. It's, anyway. No, actually, I don't have any questions. I have your document queued up to read. When I have something intelligent to say, I'll say it.
Okay, so we'll do the, we'd like an adoption call on that too. And then for dessert, there is no internet draft on this, but I want to show you an ops hack. Okay, no protocol, just an ops hack at layer 3 using L3DL. So the folk doing Kubernetes, et cetera, have, TORs connected to a rack full of servers, and servers have, they might have a NAT or whatever, and tons of microservices, maybe 100 of them on a server. Okay, and we can use L3DL to automatically build and discover this. The simple thing would just be running L3DL on the server's external interfaces and on the TORs. And you'd have an L3DL configuration to say, inject those. Well, that's fine. Now the TOR knows how to find those interfaces. Big whoopee-doo. That's not very exciting. So remember active and passive interfaces in ISIS and OSPF. Okay? Where you can say that an interface is active, excuse the Juniper, I believe. This is an active interface. It sends and receives the protocol. That's what's meant by active. And it injects its L3 addressing into the protocol. A passive interface, it does not send and receive the protocol. It's silent. but it injects the L3 information into the protocol database. So that was, thank you, the encapsulation flag for under and over. We're going to use that. Whereas the underlay is passive and the overlay is active. Actually, I think that's reversed, but the underlay overlay terminology always confuses me. But the overlay, we're going to take all these interfaces, SW0 through 7, and inject them passively into L3DL. These interfaces are active. Now, these interfaces know how to find all of these interfaces. And they can move around between servers, between interfaces here. They can be spawned, they can die, etc. Okay? You can do multi-tenancy. Just do VRFs here, do something like VXLAN here, put the matching VRFs up here, and you have multi-tenancy. Okay? So you can have a rack where microservices are moving around, etc. And remember, L3DL is going to be very quiet. It's only going to tell you when things change. Now you can turn up layer 2 liveness checking or not use it at all, but if you want detection of failures in motion, if you want to detect a server down within 1 second, 10 seconds, or 5 minutes, you can turn that on. Okay? So you can have hundreds of microservices on a server, 30 or 40 servers a rack. You can cross pods and racks. You can have service mobility and creation, deletion, microservice failure, server failure, etc. It's dead quiet. Only changes are propagated. And that's it. Hi, Paul.
Hi. So I think what you're saying is you really only need to run one instance of L3DL, then, not for all of those LLIEs or whatever that are the virtual ones in the overlay. Is that what you're saying?
Yes.
And so if there's collisions with IP addresses or things, how is that resolved? Or
Then you use the VRFs. If it's multi-tenancy, you will use VRFs, L3DL VRFs, etc.
Okay.
So they can use the same address space. That's what we mean by multi-tenancy.
Right.
That you and Sue are both using network 10.
Right. And so are those in different TLVs inside L3DL, or how do you combine them in L3DL, I guess?
Multiple L3DL instances.
Oh, so they are
In multi-tenancy, you'll need another instance per VRF.
They're multiple instances, but you only run one liveness instance. So they're not all doing hellos, making sure they're alive, or
Well, it depends upon what you want to worry about being alive.
yeah. No, I'm just
That's your choice in tuning it.
okay.
You
You're mentioning it's quiet, and so that was the part I was trying to understand.
Well, the two aspects to quiet. First of all, you tune liveness for what you want, just like you tune BFD. But the protocol only announces changes.
Right.
And that's the big thing about quiet. It's not going like ISIS and OSPF every 30 seconds hitting you on the head with a hammer.
Right. Okay.
Right? It's like BGP. It's only announcing changes. And that's all I've got. So you better ask questions because I'm well under time, right? Arigato.
Thank you. Okay, Paul?
Yeah, that's fine. Okay. So at the last IETF, we promised to produce a draft that showed how to write the LLDP TLVs for the information that is needed to be exchanged for LSVR. So that's what this draft is about. Again, so, you know, why was it motivated? As Randy just mentioned, LSVR needs to get this information to bootstrap itself. L3DL does that, uses TLV formats to do that. LLDP also uses TLVs. And so what we're trying to do is define the TLVs that could be used by LLDP to give LSVR what it needs. And also, one of the objectives I had was to demonstrate how IETF can define their own TLVs. AC pointed out that there is already a draft in IDR where that's been done. So I wasn't aware of that, but that's great. But it does point out the need for coordination in the IETF on defining TLVs for LLDP. So LLDP has a mechanism for organizations to define their own. This is the format of that. Organizations can be vendors, or they can be other standards organizations. And you stick in your OUI into the TLV itself, and you have a subtype field that must be there, and that subtype you need to manage. So that's what the IETF would need to make sure, if they're going to create their own, that they manage that space. So in this draft, what I did was go through L3DL and try to look at the information that was being exchanged there, and just simply create LLDP TLVs for that with some caveats and some things. I'll talk about that. So as I mentioned, I wasn't aware of the AC's draft in IDR. So I thought this was maybe the first time, but nonetheless, again, pointing out IETF does need to manage these, and perhaps it's RFC 5342 is the place to do that. Yeah.
Yes, this is Susan Harrison, this hat, IDR co-chair. It's an individual draft, but it is worth a read as you're on the same thing.
Yeah. Yeah, I'd already gave it a read and gave some comments back, actually, as well. Okay, so let me talk a little bit about the design of these TLVs. So the TLVs themselves have a bunch of fields in them. I didn't define those fields, just made a normative reference to L3DL. So things like the LLEI, the attributes, those in-caps flags that we just looked at, all those come from L3DL as a normative. And I did not include the per TLV signatures that are in L3DL. The way L3DL can define very large TLVs, so maybe a signature per TLV makes sense here. I think in LLDP, if we're going to do signatures, we need to do it across the entire set as opposed to inside each one. We have a limited space for a TLV. That's one of the things we need to work with. And so just some minor things, the encapsulations for IPv4 and v6, I didn't include a count when you list multiple of them because the parser could figure that out. Another thing that was important was we only want to try to run one instance of LLDP here, not an instance per interface, or be it an overlay, underlay, physical, virtual. And so the way to work around that was then to just add the LLEI into each of the TLVs. So we don't need to, again, run multiple instances of the protocol. And so in order to get the full set of information that you need, you probably have to send multiple of some of these TLVs. And that's perfectly valid in LLDP. You don't just have to have one of them. You can send 10 of the same type of TLV, just as long as they have different data, and it'll all get put together. And so I guess the other important factor is to make this really work for LSVR, we probably need to use the LLDP v2, which is going to allow you to send the amount of data that you might actually need here. So that's expected, and I'll be giving another update on the status of that protocol. So then most of these are just strictly TLV formats now. There was the attribute count, and I noticed that got changed in Randy's latest draft. So obviously I didn't track some of these changes, but this would just be simply that attribute list. The assumption would be we could fit that into a single TLV, so we should really only have one of those, not multiple of those. IPv4 announcements would have the in-caps flags and the address, and then of course you could replicate that as many times as you can to fit in the size of an LLDP TLV, so you might send multiple. So we have a V6 as well. We have the MPLS V4, the MPLS V6. I don't think we need to look at them in details. But the way the fields in there are structured, again, are either normatively referenced to L3DL or they were slightly modified to remove a count field or something. Okay, so that's sort of the main thing of the draft. It doesn't really tell you how to process them or pack them or anything like that, just trying to define them. And if we need to sign these things, we need to probably figure out maybe we should create a whole new L2 or TLV just for the signature. We could talk a little bit about that. And clearly, if we want to pursue this, if there's interest in this, we need to fix the clarifications and get it up to date with L3DL. So any questions? All right.
Randy Bush.
Yeah, Randy.
What's the rhythm? In other words, how often will I hear this stuff? And how much payload do I really get?
Okay.
And
that'll be covered in this presentation where we talk about
Gotcha.
LLDP v2. So all that other, the draft is just defining the payloads that you need. So this presentation is going to tell you about the latest status of project 802.1 ABDH. If anybody needs a secret decoder ring on the letters, meet me in the hallway. I can explain the capital upper and lowercase. They are significant. So that's what we're calling LLDP v2. So first of all, I'm giving an update on a standards project and the other SDO. This is just my personal view. Kind of need to show this slide. It's not an official liaison. Okay, if you want to do those, they pass letters back and forth. This is a much more efficient way to do it, if you trust me. So that's my discrepancy. Okay, so I've already given an update in the previous ones. There's some background material, lots of links of things that you can get history on. I didn't repeat them here. And so that's the first link. The second thing is the project has been approved. It's an official project now. It was approved in September. The most recent technical presentation is at this link, and I have incorporated a lot of it here. We just talked about the draft. And we're going to be doing a press release. 802 is going to do a press release here about the project, kind of a call for participation. We approved that last week, so I don't know when that'll go out, probably in the next couple of weeks or so, or who knows. So what are the big changes since last IETF? Just we added terminology and definitions, trying to get it ready for actually starting the documentation. There's a thing called a manifest, which is a new TLV, which effectively describes all the other TLVs. We tweaked it a little bit so that we could get the set of data that you're going to exchange to be bigger, basically, and that needs to be tuned. That's there's nothing that's up in the air on how it's a trade-off between kind of collisions, reliability, and how much data you want to send. And then there was sort of a worst-case scenario, shared media, brain dead thing where you might have multiple people with the same MAC address. I'm not going to cover that, but needless to say, that corner case has been evaluated and the protocol survives that no problem. So that's a worst case scenario you shouldn't have to worry about. Okay, so a lot of words on here and the next couple slides, but there's some good pictures that maybe make it a little more obvious. So the goal here, of course, the main goal is to send more data than can fit in a single Ethernet frame. So the big restriction with LLDP is that everything that you had to send was in one frame. You couldn't actually send multiple frames of different stuff. That wasn't the way the protocol. It was designed to be ultra simple. And so obviously there's big restrictions in that. So now we've tweaked that and you can send more than one frame, but we've tried to do it in an elegant way that is backward compatible and doesn't increase the quote chatter or amount of data that needs to be sent. So we want to support the ability to limit, also we do the opposite. So in 802, there's a thing called time-sensitive networking, which is DetNet in here at layer 3. And there's a lot of like super time scheduled stuff, and we want to be able to actually shrink an LLDP packet if we wanted to, in order to get them to fit in the timing. So this LLDP v2 actually works for that as well. So it's a separate, sort of a separate, what do you want to call it, benefit or requirement. Okay, so an important aspect of this in our approach is that an upgraded version 2 person can still talk to a version 1 person, but obviously only sharing the first PDU, because the other stuff that he wouldn't know how to do it. But so you have basic connectivity, you have the same level of functionality in an existing LLDP implementation, but you have the ability to send more data now if you support an enhancement. And so that's important because we don't have to just upgrade the world or deploy something. Shared media is supported, and obviously we want to make sure everything we send we can account for. So the other important thing, another objective, was we want to support what we call receiver pacing. So a lot of really, really small IoT type devices do things like LLDP, right? So we don't want to have them have to swallow a big giant database every time you send it. I know OSPF and IS may have had some problems like that in the past. So what we do is we allow the receiver of this chunk of a series of data to be able to request them at the pace that they can. So that means I can still have very cheap implementation of LLDP without a ton of buffering and things like that needed. And we don't want to increase the chatter any more than LLDP v1. So there is no increase. It's you simply periodically transmit exactly like you do in LLDP 1. If there's more changes in the extension data, then the receiver will request that. There's some other optimizations, that we looked at as well, or looking at, that could be considered. The project scope was written in a way that we could do, I think, some extra things if we really needed to here without too much feature creep. And then the whole authentication security, like I said, I had punted it in the previous presentation on TLVs, but we can certainly address that here by defining some secure TLVs that would provide some kind of integrity across the whole set. Okay, just a quick reminder. So LLDP, again, super simple protocol. Think of it, we like to think of it as you're exchanging a database. I have a database which is just a set, or maybe a data set is a better word, of TLVs. I have a set of TLVs and I just want to tell my neighbor about them. And if I change something, I want to tell them there's a change. And so what happens is periodically, you just go out, like in a period, it can be like 30 seconds. You would go out and you would just send, here's my latest database. Now the receiver, again, very simple. When he receives a packet from you and it checks sums out and everything's good, he throws away the old database and replaces it with what he just got. Well, he actually compares first to make sure something changed. And if something changed, he replaces it, and he tells his higher layer protocol something changed. And that's it. And then when you change something, you immediately go ahead and transmit your PDU. You don't wait for the periodic transmission. So you can get a rapid update, if you will. But things settle down, and it just basically you're just exchanging a database. So the version 2 is doing the same thing. It's just that the database now will consist of more than one packet. And so now we have to deal with, how do we know we got all the packets and blah, blah, blah. So this is where you got a lot of words. And they're basically, think of the original LLDP packet as a foundation PDU, we call it. So the original version 1 is the same as the version 1 today. It just has one additional TLV. And the additional TLV is what we call a manifest TLV. And so what that is effectively a description, cryptographic, hash, checksums, whatever, of all of the other extension PDUs. Okay, and so when a version 1 guy receives this, he's not going to know what that TLV is, so he just ignores it. He actually stores it, but he doesn't process it. He doesn't know what it is, so it doesn't do anything. He doesn't act on it. When a version 2 guy gets it, he's going to look at that manifest, and he's going to go, okay, I've got, let's say, 7 more PDUs out there. Let me make sure the ones I have match the checksums in this manifest. And if they match, then you're done. Everything's good. So I just received that one packet. If they don't match, then that receiver is going to go out and request to receive the missing PDUs. So again, the whole database, it's basically a foundation PDU plus these extension PDUs. And again, if you don't have a manifest, you act just like a regular PDU. Now, the number of additional extensions PDUs that I can add to LLDP v2 is limited by the size of a TLV. So a TLV currently is limited to 512 bytes. So that puts a restriction on how big we can make the whole thing. And that's where playing with the size of the manifest gives us a bigger set or smaller set. And so anytime a data changes in one of these extension PDUs, the manifest would get updated. That would get sent over. The receiver would notice that it's changed, and then he would ask for the changes, basically. So now we have extension PDUs. These would be ignored by a version 1, so they wouldn't even see them. The different ether type, or we've talked about various ways to do that. And then it would look somewhat like a version 1 PDU, but it would have some identifier on which extension it is. And it's sent as a unicast. So LLDP is multicast, but if you're real familiar with 802 standards, it uses one of the special multicasts, which is used to just talk to other bridges. So it doesn't flood through the network. It is stopped by every bridge. So it acts a little bit like a unicast. But if you had a true shared media, like an old repeater or something in there, it would go to every person. The extension PDUs, the new ones that we're sending, are unicast. So those would not flood anywhere or not get propagated any further than they need to. And then we have a time to live. So when you in LLDP, when you tell your neighbor about your latest state, there's a TTL that's associated with that. That means that data is good for a certain amount of time. After that time, you throw everything away, or it gets updated, refreshed. So it's, again, really pretty straightforward. That TTL will apply to all the data across all the extensions. Okay, and so now we have another protocol packet, which is the request for PDU. So this is how the version 2 person asks for all the extensions. He asks for the updates. A lot of text here. I don't know that it's overly important to go through the minutia here, but if you have questions about it, we can. I think what's probably best is to look at the actual protocol here. So here we have 2 LLDP agents on a wire. The one on the left, let's say he makes a change. He reconfigures for some reason. LSVR adds an interface. That's going to change one of the TLVs in the overall database, which is going to cause the manifest to change. And so we're going to have what we call something's changed local, which triggers me to send a PDU out. And I'll tell my neighbor, now all I'm going to send is the old-fashioned foundation PDU, but it's going to have a different manifest. So that receiver is going to get the packet. He's going to look at it. It's different than what he currently had. And so he's going to go, okay, something changed. And it's in the manifest. Something's different in the manifest. Now he's going to go about the process deciding exactly what's missing, which extension is missing, and then he'll send a request for that extension. And then, as he can consume them, the sender will unicast the information back. And then eventually you go back to everything settles down, the configuration change has been propagated, and you go back to normal LLDP operation. So that's effectively the version 2. Pretty straightforward. So I guess, Randy, to answer your question, we have the same LLDP transmission. In the TLVs I proposed in the previous draft, we only run one instance. We're not running an instance of LLDP for every virtual thing above us. So we're just running one instance on the physical wire because we can distinguish the information. And a lot of things are only sent when you make a big change. Like you're saying, whenever I make a change, the specific PDU that held that change would be requested. But you have the same periodic, like 30-second of the single foundation PDU, just like LLDP 1. So it shouldn't be, when things aren't really tweaking and changing all the time, you shouldn't really see any additional overhead than you used to. And when there is a change, then there'll be a little flurry of things, and that's it. So any other questions on how the protocol works or what we're trying to do? Pretty simple. Next steps is to continue the technical contributions. I mean, love to have an open source implementation or somebody to work with on, taking the open source LLDP and prototyping these particular changes to it so we can better evaluate that. I don't personally have the time, but I'd love to do it if I had the time. Yeah, AC.
AC of Cisco Systems. So this is good. This is happening independent of LSVR, and since you've done it, have you gotten like other use cases, people saying they're happy that this is being done?
Yeah, good point. Yeah, I mean LSVR sort of stimulated it because you had the immediate need, but there have been other people that have come up and already asked for it. So there's another standard going on, 802.1 QCJ, which it does a provider backbone bridging, ISID to VLAN mapping thing, and it's got a little protocol that sits on top of LLDP as well, and they have a need to send more data than you can fit. I didn't talk about some of the other things. I mean, general, there's a lot of vendors that have made a lot of their own TLVs, and every protocol that we keep inventing in .1, we keep adding another TLV to negotiate it. So it's definitely a need. So yeah, and this is done in a general sense, right? It wasn't just done for LSVR, but we think that was one of the key people that could use it. So again, we're in the process of saying, okay, we're going to make changes to the current standard to version 2. What are those changes? The next step is to actually create what we call an editor's draft or an individual draft, because there hasn't been an editor assigned yet. But usually that's the person who puts that together. And I welcome IETF participation. What I should have put on here was a list of when our next meeting is and how you can participate. Care?
Hey, Care Patel, Arcus. As I listen to this, I think it's an amazing thing, and I think the work should be carried out. I get a feel as I look at it this is too different to transports at a very different level, and I think we can progress both of them in parallel as long as we have a common TLV layers, and then just punt it to the industry, if you will, for lack of the better terms, to see who wants what kind of transport they need depending on how the fabrics are being built. But I think that's the way to go. That's pretty super.
Sure. I certainly wasn't proposing that this is a exclusive alternative to what's going on with L3DL. No, there's going to be other use cases for this as well. What we understand from talking to various operators is they're already running LLDP anyway, so why not? Let's try to add to it. But there certainly was an intention to be an exclusive method. And then I guess, yeah, as I mentioned, IETF people can participate. We're entering the early stages of what we call a task group ballot, and it's up to the editor. We can accept comments from anybody. It's not till you get to the later stages where it kind of gets a little bit more closed and membership required, blah, blah, blah. But early on, there's no restrictions for participating. So you feel free to do that. Yeah.
Alvaro Ratana, thanks for the update. And both you and I think Kayer sounded like you said the same thing, that 802.1 see, I can see all the words, and L3DL are two alternatives to basically do the same thing. Right? Sounded like you both said the same thing, right? No?
Well, for carrying the information that you want to exchange for LSVR, I think there's two ways to, you have two protocols that could meet that objective. The L3DL does some other things as well, but yeah, like the liveness.
Right. So the question that I want to ask, just because we need to do some coordination going forward and all that stuff. So you just said that there's some extra some extra work or some extra features in L3DL that are not covered here. So the inverse question is, does LLDP satisfy the requirements that we need for LSVR? Are there things missing that we get with L3DL that we don't get with LLDP or not?
Well, since you quoted me, Keyur Patel again.
I'm just, I don't know, you stand used to there. And this is just a question, not necessarily for you, Paul, or for anyone else. It's more a question to the, to the working group to understand where we think we are. So now he's not answering. Now he's looking the other way.
Since you quoted me, Keyur Patel, Arcus, I was simply saying they're two different transports and therefore two different semantics. As long as we have common TLV definitions and set of TLVs that go on two different transports depending on which fabric wants what transport. And like Paul said, some fabrics do deploy LLDP today, some fabrics may deploy L3DL. So I think taking both the work in parallel is
right. So yes, so what you're saying is that LSVR could use one or the other, or both, right?
I think you're Randy Bush, Arcus and IJ. They are not the same TLVs, but
Right.
that can be okay if they're the same semantics. It's not clear that they're same semantics because we haven't really dug into this. Okay. And the semantics include not just the content of the TLVs, but what happens is their state and how the two states are maintained at both ends. And what's the story about failures, et cetera. So I think, and I'm not saying good or bad, I'm saying we haven't looked. So to answer your question, I think we don't know is the only answer I could give, certainly. Right?
Okay.
But
Right. So it would be great if at some point we knew something more, right? Since there's already collaboration, cooperation, it would be nice. I did notice that you changed the TLVs. I think you said at some point that in the other presentation that it was basically the same thing. You're actually normatively referencing the L3DL draft for the definition of all the fields, but you took things out like counts or something like that. Does that mean that we can't just define the TLVs once and use them in both protocols?
No, I think you could define the TLVs once and use them in both places. I could provide this feedback to the L3DL. I don't think there was a need for some of the fields that were in the TLVs, but I certainly could have mapped it better or more identical. There's definitely a different packing problem when you look at the overall set of, if I have 50 IP interfaces that I want to advertise here, the way they get packed in LLDP is going to look different than the way they got packed in a TLV. Like there might be one TLV in L3DL, but there might be 3 or 4 TLVs in LLDP that have the same format. So no, I mean, I think it's possible to potentially define identical TLVs. The security one, I was like, again, I'm not entirely sure we want to sign every TLV. That's a discussion to have. That's probably an aspect of the way LLDP packs its TLVs because it has a restricted size. So I don't want to waste however many bytes signing every single one of them. I'd rather sign the block of them. So that's the difference. That's probably the one main difference that I see in the TLV formats. Otherwise, I think they could be identical.
Okay.
Randy again, excuse me, Alvaro, he's got a real estate problem.
Yeah.
So
For security.
we don't have a real estate problem because we can pig out. So the constraints on what happens to the TLVs and how you pack them.
Okay.
Yeah. Okay, so I'll do my best to make sure I announce to LSVR when we're, making drafts available of our protocol, and again, inviting people to participate in the process. And of course, coming to our meetings is fine too. That's great. And I can announce that as well. Whatever you guys want me to do there, just let me know. Okay, any other questions? Okay.
Okay. Well, I think we actually, are at the end here. And I also, between, the common TLV kind of structure, I think that's an important thing because, so what we have seen, for example, one of the complexities I want to avoid is between some of the, IGP TLVs being constructed and then the encoding with BGPLS involved with it. You need sometimes to have like a magical decoder ring, as was mentioned before. It would be very nice if we can actually avoid that. And for that, I would really, appreciate collaboration between the two different transport mechanisms. It would make life a lot easier going forward. And also, I think for vendors, having something common is very appreciated. So if nobody else has anything to say, then I think I'm giving you back about 20 minutes. Yes. Okay.
One last comment. I don't think we got a chance to address it while Randy was presenting L3DL, but we have an implementation for L3DL that is fully compliant, and I just wanted the working group to know. So happy to work with. If there is any other implementation out there, would be happy to do some interop testing.
Okay. Thank you.
Who has the last blue sheet? There should be one more clipboard. Okay, I'll come get it. That's good.
Okay, that's it, folks. Thank you.